Welcome back to Blueprint Bytes. In this series, we're breaking down Unreal Engine blueprints one node at a time, helping you master game development step by step. So far, we've covered the print string and branch nodes, and in both videos, we've briefly used variables, but we haven't really stopped to explain what they actually are. Up until now, the tutorials have been simple enough that we could just use them without thinking too much about it. But as we move into more complex blueprint nodes, understanding variables will be essential. In this episode, we're going to break down what variables are and why they're important, the different data types Unreal Engine provides, and also how to get and set variables within Unreal Engine. Okay, so the easiest way to explain what a variable is to tie it to some real life example. So let's think about games for a moment. Imagine you're playing an RPG and your character has a backpack, and inside that backpack you can store different types of items such as potions, gold, weapons, quest items, whatever you need. Also, maybe you have some sort of stats system for your character which has their level, health, stamina, mana, etc. All of that data is held in variables, which hold a specific piece of data that your game can check, update, or use later. Just like in a game, variables in Unreal Engine come in different types depending on what kind of data they store. Let's take a look at some examples. The simplest of the data types is the Boolean variable. It's a simple true or false question, just like asking, does your character have a health potion? If true, we can drink it. If false, we're out of luck and we're going to have to die in the street. Next up is the byte data type, which can hold small numbers between 0 and 255. Some of you might instantly recognize that 255 as a common upper limit in older RPGs. Back in the day, developers used bytes to store values like player levels or item counts, and here's why. A byte takes up exactly 1 byte of memory. If a number never needs to go above 255, why waste extra memory on the player's machine? And here's the thing, byte is extremely underrated. In a world where developers act like memory grows on trees, many skip using byte just because another data type which we're about to cover is more commonly used for whole numbers. The issue? The default whole number takes 4 bytes, while a byte only takes 1 byte. If you're storing hundreds of thousands of small numbers, that difference adds up fast. Alright, let's move on to the integer, one of the most commonly used data types in Unreal Engine. An integer, often shortened to int, is used to store whole numbers, meaning it cannot have a decimal. You can store numbers like 4 million, 420, 69, but you can't store numbers like 3.14 or 7.5 because those are decimals. And it's this trait that makes integers perfect for holding things like player score, character level, ammo count, number of enemies defeated. Unlike floating point numbers, integers don't deal with fractions. They are absolute whole values. In Unreal Engine, a standard integer can store values from around -2 billion to +2 billion. This means an integer is more than enough for most whole numbers in a game. Basically, if it exceeds 255, use an integer, unless it's a really big number. Want to store the distance from Earth to the Moon? That's too small. You're going to have to use an integer 64. And this is a pretty good time to talk about them because everything you just learned about integers also applies to the integer 64 data type. The key difference is that integer 64s can handle much, much larger numbers. While a standard integer can store values between -2 billion and +2 billion, an integer 64 can store numbers up to a staggering ±9 quintillion. This number is so large that the maximum value of an integer 64 is over 4 times the total number of grains of sand on Earth. And of course, this bigger range comes at a cost in memory usage. Instead of taking up 4 bytes like a standard integer, an integer 64 takes 8 bytes of memory. All of these ways to store whole numbers are great and all, but what if you need to store numbers with decimals like speed, damage multiplier, physics calculations, health bar numbers or whatever? That's where float comes in. A float is a floating point number, meaning it can store decimal values like 3.14, -0.5, or 99.999. Unlike bytes, integers, and integer 64s, which are always whole numbers, floats let us work with fractions and precise calculations. For example, we might have character speed moving at 3.75 units per second, or a weapon stat multiplier, such as a sword with a multiplier of 1.5 damage against dragons. If you're working with anything that needs precision, floats are the way to go. And they take 4 bytes of memory just like an integer. Quite often we aren't dealing with numbers, we need to store words instead. That's where name, string and text come in, and I'm going to cover them all at once here because they're really quite similar. A name is a simple, efficient identifier used internally by Unreal Engine. You'll see it used for things like actor names, object references and IDs. It's super fast. Name variables are highly optimized for speed. They are case insensitive, so player 1 with an uppercase P and player 1 with a lowercase p are treated as the same. They are immutable though, so once you've set them, you cannot change their value. Think of name as a tag, great for internal tracking, but not meant for player visible text. A string is the most flexible text type, and it can be used to store any text, including spaces and special characters. It can be changed and updated at any time, and it supports full text formatting, like combining multiple strings together. Use a string when you need to store player names, dialogue text, chat messages, or any text that the player will see or edit. Now, let's talk about text. At first glance, text seems just like a string, but it has one key advantage. It's designed for localization. It supports multiple languages out of the box, and Unreal can swap text values based on the player's language settings. This does come at a cost though. Text is more memory intensive than strings, so only use it when localization matters. If your game needs multiple languages or dynamic UI text, use text instead of string. It makes translation easier without needing to rewrite your entire system later. When working in a 3D world, objects don't just have a position, they also have a rotation. That's where a rotator type comes in. A rotator stores rotation angles, allowing Unreal Engine to determine which direction an object is facing in 3D space. Instead of just one value to track rotation, rotators have 3 separate angles: pitch, yaw, and roll. To make this easier to understand, let's compare it to how a human moves in the real world. Okay, so first let's jump in and take a look at pitch. This controls up and down movement, just like when you nod your head to say yes. If you increase the pitch, your character or object tilts upward. If you decrease it, they tilt downward. In games, pitch is commonly used for things like aiming a weapon or looking up and down with a camera. And next up we have yaw. This controls left and right movement, just like when you turn your head from side to say no. Imagine standing up and spinning in a circle. That's yaw in action. Yaw is used all the time in Unreal Engine for things like turning a car left or right or rotating enemies to face the player. And finally we have roll. Roll controls side to side tilting, like when you lean your head or roll down a hill. Roll is most commonly used for flying mechanics like airplanes and spaceships, or tilting a camera for cinematic effects. It's also used for balancing animations like a character shifting weight while running. Rotators are essential for making movement feel natural in 3D space. Without them, characters and objects wouldn't be able to turn, tilt, or look around. In Unreal Engine, rotators are used in player movement, AI behavior, vehicle physics, and even camera animations. Anytime something needs to rotate smoothly, you'll likely be working with a rotator variable. Okay, so we've covered rotators, which define where something is facing in 3D space, but what about where something actually is in the world? That's what vectors are for. A vector represents a position or direction in 3D space using 3 values: x, forward and backward; y, left or right; z, up and down. If you've ever played a game with a mini-map, you've already seen a vector in action because your position in the game world is tracked using x, y, and z coordinates. To go into a little bit more detail though, those x, y, and z values are represented with floating point numbers, and you can think of running straight ahead or stepping back for the x-axis, and you can think of sidestepping or strafing in an FPS when using the y-axis. Regarding the z-axis, that's for things like jumping or falling. These 3 values together define exactly where something is positioned in 3D space. So basically, vectors in Unreal Engine serve 2 main purposes. The first is obviously position, which defines an object's location in 3D space. And the second is direction, which represents movement or force pointing in a specific direction without a fixed position. And I know that second point seems a little complicated, but in reality it's pretty easy if you think about it in a real world example. Imagine running against a wall and bouncing off of it. The second point there was really about the force in which you are moving in a given direction, and you can use vector math to apply those direction changes as well. Great, so we've talked about vectors and we've talked about rotators for position and rotation respectively, but what if we need to store everything about an object's placement in 3D space, its position, rotation, size in one neat package? That's exactly what the transform type does. We can think of transform as a combo pack that includes three essential properties about an object in 3D space. Its vector for its position, its rotator for which way it's facing, and also its scale, as in size, how big or small it is. Instead of keeping these values as separate variables all over the place, the transform type bundles them together, making it easier to move, rotate, or resize objects with a single variable. Transforms are the backbone of how objects exist in 3D space. Without a transform, Unreal Engine wouldn't know where something is, which way it's facing, or even how big it should be. They're used in almost every blueprint. Every actor in Unreal has a transform. They're essential for physics, animation, and AI. Everything that moves, rotates, scales, whatever, they all need transforms. They're crucial for parenting objects. If a sword is attached to a player, its transform updates relative to the player's transform. Alright, we've now covered all the major variable types in Unreal Engine. Booleans, integers, floats, vectors, rotators, transforms, all the text-based types. We've explored what they are, how they work, and when to use them. But knowing what they do is only half the battle. Now it's time to put them into action inside of Unreal Engine. So as you can see, I'm just here inside of my third-person project. And we're just going to do it like we've always done it and add it into the third person character. Now, I'm just going to go and create a quick Boolean variable here. I'm just going to go ahead and call it Boolean for the sake of this tutorial as well. And then you'll be able to see on this drop down here that you can select the type. And these are all the types that we've been looking at in this video so far. Now, I'm not going to make you sit and watch me create all of these. So I'm going to go ahead and create all of them, basically just one variable for each of those types with the same name as the type just to show what it is. As you can see here, I have all these variables created and I'm going to quickly just walk through how to get and set values on them. So first I just want to show how to get the value of a variable. I'm going to go ahead and start with a string. So just drag the variable out onto the graph and then be sure to select get. And with that, our variable is now added to our graph, so we can now get the value of it at any point. Now I'm just going to hit compile so that I can set a default value on this string over here on the right. And I'm just going to set it to testing with default value or something like that. And then next up, I'm going to go ahead and add the event begin play, just like we did for the print string example. And from there, we're just going to then drag out of our execution pin for the begin play event to a print string node. And then we're going to drag our string variable to that node and hit compile, save, and then close this and hit play. And there we see our message, and that's our variable working. Now, getting the values of variables and printing them to the screen is great and all, but we're building a video game. We're going to want to be changing the values of variables constantly. Let's have a look at how we can change the value within that string variable and then print that new value to the screen. So the first thing you're going to want to do is open up that blueprint for the third person character again. And the first thing we're actually going to do is delete that getter we just created. And then we're going to move the print string node off to the right. And then we're going to drag our variable back in, but this time we're going to select that setter. Then we're going to put it in between and connect the execution pins up so that it flows through the setter, changing the value before going to the print string. Then I'm going to put a value in here. I'm just going to put new value, exclamation marks. And then I want the value that comes out of that setter as well to go into that print string node. I'm going to hit compile. I'm going to save it. I'm then going to close this, go back to the main editor and hit play. And there's our new value. Now that we've seen how to get and set a string variable, you might be wondering, what about the other types? Well, here's the thing. They all work the exact same way, whether it's a Boolean, integer, float, vector, pretty much any of the other types. You'll use get to retrieve the value and set to update it, just like we did with the string. Rather than making you sit through the same process over and over again, I'll spare you the repetition. Just know that you'll be using getters and setters the same way across all of these variables in your projects. And the real takeaway from this lesson was to understand what each data type does and to get a quick look at how we manipulate data inside of Unreal Engine. Now that we've covered the fundamentals, we can start to move on to more advanced nodes in future lessons. For the sake of seeing them though, here they are all presented in the graph, just separating the getters and setters from each other. And that's a wrap on this episode. We covered all the major variable types in Unreal Engine, how they work, and how to get and set values of variables. If you find this video helpful, please make sure to like and subscribe. It goes a long way towards helping me make future episodes. And that's pretty much it. Thanks. Bye.